Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2018, so let's get started. First problem, Kate bakes a 20-inch by 18-inch pan of cornbread. The cornbread is cut into pieces that measure 2 inches by 2 inches. How many pieces of cornbread does the pan contain? Okay, so we have this 20 by 18-inch pan, and then we have, this is 20, this is 18 inches, but then the pieces are 2 inches by 2 inches, right? And so this will become 10 pieces, and 18 inches is equal to 9 pieces, right? So the total number of pieces is 9 times 10 equals 90. So the answer is A. Number 2, Sam drove 96 miles in 90 minutes. His average speed during the first 30 minutes was 60 miles per hour, and his average speed during the second 30 minutes was 65 miles per hour. What was his average speed in miles per hour during the last 30 minutes? Okay, so his total distance is 96 miles, right? 96 equals his distance for the first 30 minutes. So his distance for the first 30 minutes, that is 1/2 hour. So because that's half an hour times 60 miles per hour plus, and then the second was 65, half times 65 plus, and then if we see that what we want to get is x, that will be 1/2 times x, right? And so if we multiply 2 by 2 on both sides, that would give us 192 equals 60 plus 65 plus x, and so x equals 192 minus 125. This equals 70. No, this equals 67, right? So the answer is 67 minutes. No, the answer is 67 miles per hour. It's D. Problem number 3. In the expression this, each blank is to be filled with one of the digits 1, 2, 3, or 4, with each digit being used once. How many different values can be obtained? Right. Okay. So since this and this has, yeah. So since they look the same, right? And so all we need to do is look at how many different combinations of 2 and 2 that we can get, right? And so we can have 1, 2 combined, or 1, 3 combined, or 1, 4 combined, and this will lead to 3, 4 combined, 2, 4 combined, and 2, 3 combined. So we have 3 different cases. That means we have 3 different values that can be obtained. The answer is B. Number 4, a 3-dimensional rectangular box with dimensions x, y, and z has faces whose surface areas are like this, square units. What is x plus y plus z? Okay, so since we have 24, 48, 40, 72, and 72, we have to find x, y, z, where x, y equals 24, y, z equals 48, and x, z equals 72. Right, and so if we think about 24, we can get 4 times 6, right? But that we don't know what x or y is, which one's x and which one's y, right? And so for 6, this would be, for 4, this would be 4 times 12, and then 6 times 12, that is 72. Oh yeah, so we did get the values for x, y, and z. So x and y and z are 4, 6, and no. So x is 4, no, so sorry, x is 6, y is 4, and z is 12. And so x plus y plus z equals 22. The answer is B. Number 5, how many subsets of this contain at least one prime number? Okay, so what we have to do is the total number of subsets for 2, 3, 4, 5, 6, 7, 8, 9 minus the number of subsets for just the non-primes, so just the composites, right? Composites. And so the composites here are 4, 6, 8, and 9. And so the number of subsets for 2 to 9, there are 8 terms. No, there are 8 values. So this is 2 to the 9th. No, this is 2 to the 8th power. And since there are only 4 values in the subset of the composites, then this would give us 2 to the 4th power, right? And so this is 2 to the 8th power minus 2 to the 4th power equals 2 to the 4th power squared minus 2 to the 4th power. So this is 16 squared minus 16. This is 16 times 15, right? But then 16 times 15, the units digit, so the units digit is 0. And so the only answer choice with the units digit of 0 is D, 240. So the answer is D. Problem number 6. A box contains 5 chips, number 1, 2, 3, 4, and 5. Chips are drawn randomly, one at a time without replacement, until the sum of the values drawn exceeds 4. What is the probability that 3 draws are required? Yeah, so the highest number of draws needed is 3, right? Because even if we are choosing the three lowest values, it will be 1, 2, and 3, and that is greater than 4, right? And so what we now have to do is find the total possibilities, and then subtract from that the probability of one draw and the probability of two draws, right? And so the probability of one draw, that would be 1 over 5, right? Because the only way to do that would be just to get 5 on the first turn. And for P2, that would be if we draw 1 first, we would need 4 or 5, so that would be 2. If we draw 2 first, then we would need 3, 4, or 5, so we would need 3. If we draw 3 first, then we would need 2, 4, or 5, so that will also be 3. If we draw 4, then that would be 1, 2, 3, or 5, they would all work, so that's 4. And 5, that would just be P1, right? And so this is 2 plus 3 plus 3 plus 4, which is 12, right? So 12 over 25 because, no, sorry, 12 over 20, because it's 5 times 4, this equals 3 over 5, right? And what is the and so the total possibilities is just 1, right? So it's 1 minus 1 over 5 minus 3 over 5. The answer is 1 over 5. The answer is D. Problem number 7. In the figure below, n congruent semicircles are drawn along a diameter of a large semicircle with their diameters covering the diameter of the large semicircle with no overlap. Let A be the combined area of the small semicircles, and B be the area of the region inside the large semicircle but outside the small semicircles. The ratio A to B is 1 to 18. What is n? Right. Okay. So, this is n number of semicircles, and if we say that the radius of the small semicircle is 1, then that means the radius of the large semicircle is n, right? And so since A to B is 1 to 18, that means small to whole minus small is 1 to 18. So that means that the ratio of the small to whole itself, that will be 1 to 19, right? And so since the radius of the large one is n, that means the area of the large semicircle, this is 1/2 times n squared times pi, and the area of the small semicircle times n, because there are n of them, this equals 1/2 times 1 squared times pi times n, right? And so this is pi over 2 n squared, and this is just pi over 2 n. And so 1 to 19 is this to this, and so that's the ratio. And as you can see, this is exactly n times greater than this, and so here 19 equals n equals 19. The answer is D. Number 8. Sarah makes a staircase out of toothpicks as shown, like this, right? This is a 3-step staircase and uses 18 toothpicks. How many steps would be in a staircase that used 180 toothpicks? Okay, so first let's see. For a 1-step staircase, that would just use 1, 2, so 2 pairs, so 2 times 2. And a 2-step staircase, that will use 1, 2, 3, 4, 5, right? And so that's 2 times, and then 2 on the upper, 3 on the lower, right? So that's 2 plus 3. And if we have 3 steps, we add to the 1, 2, 3, 4, right? And so that's 2 times 2 plus 3 plus 4, and until on we go. For the nth step, that would be 2 times 2 plus 3 plus 4 plus all the way 2 plus n plus 1, right? And n plus 1, like this. And this should be 180, right? And so we want to find the value of n. But then here we see that 2 plus 3 plus 4 all the way to n plus 1. This equals 90, right? And then if we do plus 1, then 90 plus 1, that would just be 91, right? So 91, and this would give us all over 2 n plus 1, n times 2, right? no, n plus 2, right? So this equals 91. So n plus 1 times n plus 2 equals 182. So this is, what is it, 13 times 14, right? And so n plus 1 equals 13, so n equals 12. The answer is 12, it's C. Number 9, the faces of each of 7 standard dice are labeled with integers from 1 to 6. Let P be the probability that when all 7 dice are rolled, the sum of the numbers on the top faces is 10. What other sum occurs with the same probability P? Okay, so the sum of the numbers on the top faces is 10. That means that the the lowest value that each dice can get is 1, right? So there will be at least 7 ones. And we need 3 more, right? Plus 3 more, and so those 3 more will be like 1 1 1, like that, right? But then we don't need to get this probability. We just need to see what other sum occurs with the same probability P, right? And so if you see here, this one, these were the minimum values of the dice that it could get, right? And so for the same and for the other sum that occurs with the same probability, then we need one with the maximum sum, with the maximum value, right? And so that would be 6, right? 6 6 6 6. We have 7 sixes, and then we had 3 extra that could just go anywhere, right? And so same thing for here, we have 3 extra, like minus 1 minus 1 minus 1, right? And so this would give us, this whole thing would give us 6 times 7 minus 3 equals 42, minus 3 equals 39. So the answer is 39, it's D. Number 10, in the rectangular parallelepiped shown, is that how you read it? AB is 3, BC is 1, and CG is 2. Point M is the midpoint of FG. What is the volume of the rectangular pyramid with base BCHE and apex M? Right, so we want the volume of this, we want the volume of this thing. And so to get that, we first have to know the distance from M to EHBC, and so this would have to be right angle, right? And then this point would be on the exact midpoint line of EH and BC, right? And so it would be like right there. So this would be that point. And so this length would be equal to, if we move this kind of whole like new setup triangle by if we move this new setup triangle forward like this, then that would just be equal to this EFB, right? And so this so that length would be equal to this length, where if you see, that would just be this length, right? With this is a right angle. And so since this length is 3, this length is 2, right? So I'll write that down, this is 2. And then we can know this length of EB, right? And if we see EB is root 13. And so this length, let's call that x equals 2 times 3 over root 13. This is 6 over root 13. And so there we have it. Our height of the rectangular pyramid is 6 over root 13. And now the base is BCHE, and since this is 1 and this is root 13, base is 1 times root 13, which is just root 13. And so the volume of the pyramid is 1/3 times base times the height, which is 6 over root 13. These two cancel to make 2. The answer is 2. So it's E. Number 11. Which of the following expressions is never a prime number when P is a prime number? Okay, so we have P squared plus 16 all the way to P squared plus 96, like that, right? But then first of all, let's try P equals 5. And so if P equals 5, then P squared plus 16 equals, then P squared plus 16, this becomes 25 plus 16, so it is 41. And P squared plus 24, that is 49. P squared plus 26, that is 51. P squared plus 46, that is 71. And P squared plus 96, that would be 121, right? And so these two are prime numbers, so they are not the answer. And if P is 7, P squared plus 24 would be 49 plus 7. No, it would be 49 plus 24, right? And so that will be 73. And p squared plus 26 would be 49 plus 26, which is 75. And p squared plus 96 would be 49 plus 96, which is 50 plus 95, which is 145. And so this is a prime number, so that is wrong. And lastly, if p is 19, then p squared plus 26, 19 squared equals 361, right? And so 361 plus 26, that would be 387. And p squared plus 96, that would be 361 plus 96, which is 457, right? And this is prime, so that is wrong. And 387, this is a multiple of 3, right? And so this is the only answer choice left. It's C. Number 12, line segment AB is a diameter of a circle with AB equals 24. Point C not equal to A or B lies on the circle. As point C moves around the circle, the centroid of triangle ABC traces out a closed curve missing 2 points. To the nearest positive integer, what's the area of the region bounded by this curve? Okay, so we have a circle like that, and then we have the diameter AB equals 24 like that. And so this would be A, this would be B, and this would be the midpoint, right? And then point C, let's see, it's just here. As point C moves, yeah, so the centroid of triangle ABC, right? So we need triangle ABC, and we need to get the centroid of that, right? And so if we have this triangle, then that means this is the radius, and the centroid of this triangle will be the point on this line where it's 2 to 1, right? So right here, this would be 2 to 1, right? So that point would be the centroid, and as C moves along like that, this would also kind of move like that. And so if it's there, it would be the 2 to 1 point, right? Yeah, it would be the 2 to 1 point like that. And so it would go here. If it's here, then the 2 to 1 point would be like that. So it would go here, and so on. And so the centroid would make this kind of circle, right? And so that would be so this would be the region bounded by this curve, and it's missing these 2 points because it said that C is not equal to A or B, right? And so it asks the area of the region bounded by this curve. That just is asking for the area of this circle, right? And so since AB is 24, that means this much is 1/2 of it, so that's 12, and this much is 1/3 of the radius, so that is 1/3 of 12, so that is 4, and so the radius is 4. So the area, this is pi r squared, this is pi times 16 pi, and so pi is 3.14 something, right? So 16 pi equals 16 times 3.14. This is 48 plus 0.14 times 16, and so this is small value, and 48 is like a different value, so the value closest to 48 from the answer choices is 50, so the answer is C. Number 13, how many of the first 2018 numbers in the sequence this are divisible by 101? Okay, so first of all, 101 is divisible by 101, obviously, and if we keep going, we will find that 1000001 with 5 zeros, this is also divisible by 101. If you divide this by 101, then you get 9,901, right? And so this gives us that 1 0, okay, and this gives us that 5 zeros are also divisible by 101, right? And so this pattern will continue. So so the number of zeros would be 1, 5, and then add 4, so 9, and then add 4, so 13, and so this will be 4x minus 3, right? And so of the first 2018 numbers, we have to find the number of x's, right? And so 4x minus 3 is less than or equal to 2018, and so 4x is less than or equal to 2021, and so x is less than or equal to 505.75, and so that means x can be all the way from 1 to 505. So this is 505 values. The answer is C. Number 14, a list of 2018 positive integers has a unique mode which occurs exactly 10 times. What is the least number of distinct values that can occur in the list? Okay, so we have so the mode occurs 10 times. So all the other numbers can occur for a maximum 9 times. Maximum 9 times, right? Okay, so first we'll just have 1 for the mode, and so that will leave us with 2008 integers, right? And then the others is maximum 9 times, but then we want the least number of distinct values that can occur in the list, so we will divide this by 9, right? And so that gives us 2008 divided by 9. That will give us 223 with a remainder of 1, right? And so we have 223 numbers occurring 9 times, and one number which occurs once, right? And then we also have the mode which occurred 10 times, right? So we have 223 numbers plus one number plus one number. That would give us 223 plus 1, which is 225. The answer is D. Number 15, a closed box with a square base is to be wrapped with a square sheet of wrapping paper. The box is centered on the wrapping paper with the vertices of the base lying on the midlines of the square sheet of paper as shown in the figure on the left. The four corners of the wrapping paper are to be folded up over the sides and brought together to meet at the center of the top of the box, point A in the figure on the right. The box has base length W and height H. What is the area of the sheet of wrapping paper? Okay, so since it said that the corners are folded up over the sides, that means that this length, so this length right here, that is the height, right? So this much is H, and we want the area of the sheet of wrapping paper. So this is W, and so this is also W. That means this this length is W, right? And so this length would be W over root 2. And because of the same reasoning, this length would be H over root 2, right? Because both of these triangles are isosceles right triangles, and since this is since this and this length is the same, then our whole side length is 2 times W over root 2 plus H over root 2. This equals root 2 times W plus H, and so the area is side squared, so root 2 times W plus H squared. This is 2 times W plus H squared, right? So 2 times W plus H squared is our final answer. The answer is A. Number 16, let A1, A2, all the way to A 2018 be a strictly increasing sequence of positive integers such that this. What is the remainder when this is divided by 6? Okay, so in order to solve this problem, you must know the fact that A1 cubed plus A2 cubed plus A3 cubed all the way to AN cubed. This is equal to A1 plus A2 plus A3 plus all the way to AN. This whole thing squared, right? And in this case, n is 2018, right? And so this is a 2018, and this is a 2018. And so we want this value, actually the remainder of that value when it's divided by 6. But then this is equal to, we know that this much is 2018 to the 2018th power. So if we just put that in there, we can get 2018 to the 4036th power, right? And so we want the remainder when 2018 to the 4036th power is divided by 6. So first of all, 2018 divided by 6. Yeah, so 2018 to the first power divided by 6. This has a remainder of 2. And 2018 squared divided by 6. This has a remainder of 4. And if you keep going, you will find that the remainders are alternating between 2 and 4, right? But then what we want is 2018 to the 4036 value, so this is even, right? So this is even, and so the remainder for the even exponents is 4, so the answer is 4, it's E. Number 17, in rectangle PQRS, PQ equals 8 and QR equals 6. Points A and B lie on PQ, points C and D lie on QR, points E and F lie on RS, and points G and H lie on SP, so that AP equals BQ is less than 4. And the convex octagon ABCDEFGH is equilateral. The length of each side of this octagon can be expressed in the form k plus m root n, where k, m, and n are integers, and n is not divisible by the square of any prime. What is k plus m plus n? Okay, so if we draw this, our diagram will be something like this, right? And so PQ, this whole thing is 8, and this is 6, right? And if we say AB length is 2A, then AH will be 2A also, right? But then if we can divide it in half, this much will be A, and since the whole thing is 8, the half will be 4, so that means that this much will be 4 minus A. 4 minus A, and by the same way, if we do that, then this will be A and this will be 3, so and that way this would be 3 minus A, right? And so we can use Pythagoras here with this right triangle. 2A squared equals 3 minus A squared plus 4 minus A squared, and so 4A squared equals A squared minus 6A plus 9 plus A squared minus 8A plus 4 plus 16, and so 2A squared plus 14A minus 25 equals 0, and so to solve this, we need to use the quadratic formula, and so that will be all over 2, and then 14 divided by 2 is 7, so minus 7 plus or minus root b squared, so that would be 7 squared minus AC, so plus 50. So this equals all over 2, and then minus 7 plus root 99, and so this is plus 3 root 11, right? And so this is A, and so 2A would become this much. So so this is negative 7 plus 3 root 11. So this means K equals negative 7, M equals 3, and N equals 11. And so if we add these up, this gives us 7. So the answer is B. Problem number 18. 3 young brother-sister pairs from different families need to take a trip in a van. These 6 children will occupy the second and third rows in the van, each of which has 3 seats. To avoid disruptions, siblings may not sit right next to each other in the same row, and no child may sit directly in front of his or her sibling. How many seating arrangements are possible for this trip? Okay, so if we have brother-sister pairs of AA, BB, and CC, the capital letters are to distinguish between the different children. And we have 6 seats, right? And so siblings can sit like this, or the siblings can sit like this, right? In like flipped. And so it asked how many seating arrangements are possible. And so first we have two configurations to choose from. So we have 2, and then multiply that by choose which sibling will sit in the front row, which sibling will sit in the front row, which sibling will sit in the front row. So that will give us 2 cubed, right? 2 cubed, and then multiply that by for each of these pairs, which pair will sit in which seat. And so that is just 3 times 2 times 1, so that's just 3 factorial. So this is 2 times 8 times 6 equals 16 times 6 equals 96. So the answer is D. Number 19. Joey and Chloe and their daughter Zoe all have the same birthday. Joey is 1 year older than Chloe, and Zoe is exactly 1 year old today. Today is the first of the 9 birthdays. on which Chloe's age will be an integral multiple of Zoe's age. What will be the sum of the 2 digits of Joey's age the next time his age is a multiple of Zoe's age, right? And so what this gives us is that Chloe, Chloe minus Chloe's age minus Zoe's age, Chloe's age minus Zoe's age. This has 9 divisors, so 9 factors, right? The only kind of plausible number with 9 divisors is 36. So this is 36 because 36 has 1, 2, 3, 4, 6, 9, 12, 18, 36. Those as factors, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 factors in total, right? And so the age gap between Chloe and Zoe would be 36. And so this means that Chloe is 37 years old because Zoe is exactly 1 year old today. And so for Joey's age, Joey is 1 year older than Chloe, so Joey is 38 years old today. And the gap between Joey and Zoe, so Joey and Zoe, this is 37, and this is a prime number, right? And so the next time his age is a multiple of Zoe's age will be when Joey's age is 2 times Zoe's age, right? And so the Zoe's age will have to be 37. So Joey would be 74 years old, right? And so the 2 digits of Joey's age would be 7 and 4. The sum is 11, so the answer is E. Number 20, a function f is defined recursively by f1 equals f2 equals 1 and fn equals this much. For all integers, n is greater than or equal to 3. What is f 2018? Okay, so first let's write out the f values. So if f is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, like that, right? And then let's write so this is supposed to be the x values, and this is supposed to be the f values, right? Less x values, more n values, right? f1 and f2 is 1 and 1, and f3, this would be 3 plus 1 minus 1, so that would be 3. f4, that would be 4 plus 3 minus 1, so it's 4 plus 2, which is 6. f5, that would be 5 plus 6 minus 3, that would be 8. And then for 6 plus 8 minus 6, that is 8, and so on. If we just keep writing this, we will get 7, and then the next one's going to be 7, and then 9, 12, and then minus, so 14 and 14, and we have 13, and we have 13, and we have 15, 18, 20, like that, right? And then we can keep going, but then right here we can see kind of like a pattern, right? So we can split this by 6, right? Yes, so this we will need 18 here too, and then this will be 20, right? So we can split it like there, right? And so if you see, these are the same, and for the one in the middle, the f value is 1 less than the n value, right? Same for this, these two are the same, and the middle one is less. And also same for here, right? And so by this, if we can find out if f 2018 is 6 times something plus the remainder, right? If we can find out the remainder, if 2018 is divided by 6, then we can get the answer, right? And so 2018, this is 6 times 336 plus 2, right? So it's the second one, and so it will have this same pattern, right? And so since the n value is 2 and the f value is 1 minus the n value, that means the f value is 2018 minus 1, so this is 2017. So the answer is B. Number 21. Mary chose an even 4-digit number, n. She wrote down all the divisors of n in increasing order from left to right, 1, 2, all the way to n over 2 and n. At some moment, Mary wrote 323 as a divisor of n. What is the smallest possible value of the next divisor written to the next of 323? Okay, so the first thing that we have to do here is we have to dissect 323. And so if we do that, 323 is 17 times 19, right? And so n has factors 2, 17, and 19. These three for sure, right? And we want the smallest possible value of the next divisor, and it has to be 4 digits still, right? And so 2 times 323 is 646, right? And so 646 times something equals still 4 digit, right? And so if the unknown value, if this one is 10, right, then it will be 6460, so that will still be a 4-digit number. And and if we have another factor of 10 here, right, then the next value would be 17 times 2 times 10, and that will be 340. So that is, yeah, so 340, that's the smallest possible value of the next divisor. So the answer is C. Number 22, real numbers x and y are chosen independently and uniformly at random from the interval 0, 1. Which of the following numbers is closest to the probability that x, y, and 1 are the side length of an obtuse triangle? Okay, so if we draw a graph, then we have x and y. So this is x and this is y. And we have them from the interval 0, 1, 0, 1, right? Like that. And so which of the following numbers is closest to the probability that x, y, 1 are the side length of an obtuse triangle, right? But then it has to be obtuse, so x plus y has to be greater than or equal, has to be greater than 1, right? Triangle inequality, right? And the reason that x or y can't be the largest value is because x and y are limited to 1 as their maximum, right? And so if we draw that, this is our x and y boundaries, and x plus y is greater than 1. That would be, we would have this line here, and then that would mean this area, right? And so the area to the right of y equals negative x plus 1. And then it has to be an obtuse triangle, right? And so using that, since we have like x and y and 1, that means that x squared plus y squared is less than 1 squared, right? And so x squared plus y squared equals 1 squared, and then we have to be inside this, right? And since x squared plus y squared equals 1 squared is a circle with radius 1, that would be something like this, right? That would be like this, right? With this as the center, and this is supposed to be inside this, and so our possible values would be somewhere inside here, right? But then, as I said before, this is this area, and so the overlapping area, that's this much, right? That is just this much. And so if we want to get that overlapping area, we first have to get the area of this quarter circle, and then we have to subtract this 1/2 from it. Yeah. So our answer is 1/4 times 1 squared pi, which is pi, and then minus 1/2, right? Minus 1/2 equals pi over 4 minus 1 over 2. So this is our answer, but then it's just seen in decimal form. So that is 3.14 over 4 minus 0.5. So minus 1 over 2. This is 3.14 minus 2 over 4. This is 1.14 over 4. And so we got 1.14 over 4. And this is greater than 1/4. But this is less than 1 over 2. And so this is between 0.25 and 0.50. So it is 0.29, which is between 0.25 and 0.50. So the answer is C. Number 23, how many ordered pairs a, b of positive integers satisfy the equation this, where GCD a, b denotes the greatest common divisor of a and b, and LCM of a and b denotes their least common multiple. Okay, so here life will be very, very much easier if you know that LCM of a and b, multiplied by the GCD of A and B equals just A times B, right? And so if we use this, then we get that this is just LCM times LCM of AB times GCD of AB. And so if we say that LCM of AB is X and GCD of AB is Y, then we get that, we can erase this, we get that XY plus 63 equals 20x, equals 20x plus 12y. And so xy minus 20x minus 12y plus 63 equals 0. X minus 12, x minus 12, and y minus 20. That will be the factorization. But then we have to do 63, and right now we have 240. So this is 240 minus 63, which is 177, right? So this is 177. And that way we can have this is 177 and this as 1, or we can have this as 59 or this as 3, and we can't put y minus 20 as greater than x minus 12 because x is the least common multiple and y is the greatest common divisor, and so x is always going to be greater than y, right? And so if x minus 12 is 177 and y minus 20 is 1, so in this case we get that x equals 189 and y equals 21. And in this case, we get that x equals 71 and y equals 23, right? But then one more thing about x being the LCM of A and B and y being the GCD of A and B. That means that x is always going to be a multiple, so x is always going to be an integer multiple of y, right? And so x has to be an integer multiple of y, and 71 is not an integer multiple of 23, so this cannot be the answer. So x is 189, y equals 21. 189 is 9 times 21, so this does meet that condition. And so it asks for how many order pairs of A and B, but then x and y is just the LCM and the GCD of A and B, right? And so A and B values, or yes, so if we get two values from the LCM and GCD being 189 and 21, they can just be switched around, right? So that's just two values. So the answer is 2, it's B. Number 24. Let ABCDEF be a regular hexagon with side length 1. Denote by x, y, and z the midpoints of sides A, B, C, D, and EF respectively. What is the area of the convex hexagon whose interior is the intersection of the interiors of triangle ACE and triangle XYZ? Okay, so let's so first let's try to draw this as a diagram. So this would be our diagram, right? And so the side length of 1, so the side length is 1, right? But then let's just say that AF side length is 4, for just making the math easy, right? And we'll just multiply 1/4 later on. And so if one side length is 4, then AX this will be 2, right? And then since this is a 30/60, since that's a 30/60/90 triangle, because this is 60 and this is also 60, right? And so this would be 1 and this would be √3, right? And so what we want is the area of this hexagon, and we can get that by getting AEC and then subtracting from it these 3 triangles, right? And so if we do that, first of all, AEC, this is 1/2 of ABCDEF, right? Because if you just connect these lines like that and like that, right? Then this area is equal to this area, same thing, this area is equal to this area, and this area is equal to AFE, right? And so the middle area is 1/2 of the whole thing, and so this equals 1/2 times ABCDEF is 6 times side 6 times side length 4, 6 times side length 4 equilateral triangles, right? So √3/4 times 4 squared. So this equals 3 times 4, so it's 12√3. And for these triangles, we are basically already there because we found that this is √3, and this triangle is also a 3069 triangle, right? And so this would be 3 and this would be 2 root 3. And so one of these area, one area would be root 3 times 3 times 1/2, because this is a right angle. And so we have to multiply this by 3 because there are 3 of it, this one, and this one, right? And so this equals 9 root 3 over 2. And so what we want to do is 12 root 3 minus 9 root 3 over 2. 12 root 3 minus 9 root 3 over 2. This would equal 24 minus 9, so that's 15 root 3 over 2. And so this is when, so that value is when we put AF to be 4, right? But then since we increased the length by 4 times, then that means we must have increased the area by 16 times, right? And so this is the 16 times bigger area, and so we want the original area, right? So original area, this equals 15 root 3 over 2 divided by 16. This equals 15 root 3 over 32. So this is C. So the answer is C. Last problem, number 25. Let the floor of x denote the greatest integer less than or equal to x. How many real numbers of x satisfy the equation of this, right? And so since we have both 10,000 and 10,000 here, we want to just make them into one thing, right? So x squared equals 10,000 times x minus the floor of x, right? But then since x floor is the greatest integer less than or equal to x, that means x minus the floor of x would be the decimal part of x, like that, right? And so since this is the decimal part of x, if we were to isolate that, x squared over 10,000 would be the decimal part of x. And then we know that the decimal part of x, actually the decimal part of any number, this is between 0 and 1, right? And so since this is the decimal part, we can just put that into these restrictions, right? Like that. And then we will get this thing, right? And here we see that since x is squared and 10,000 is 100 squared, right? And so if we were to do splitting like this and like this, that will give us two kinds of so that would give us two things. First is that 0 x squared, so 0 is less than or equal to x squared over 100 squared. So x squared is greater than or equal to 0, and so x is greater than or equal to 0, or x is less than or equal to 0. So this doesn't really have any meaning here. And the next thing it gives us is with this, right? And so x squared over 100 squared is less than 1. So x squared is less than 100 squared. That means x is greater than negative 100 and less than 100. And so this is our restrictions for s, right? So how many real numbers x satisfy the equation of this, right? And so since x is between negative 100 and 100, that means x can be from negative 99 all the way to 99, right? And so this is from negative 99 to negative 1, and then from this to 0 to 99. So we have 100 numbers here and we have 99 numbers here, so this is 199. So the answer is C. So that was the last problem for the AMC 10B for the year 2018, and thank you for watching.